Memory prices are about to double, not gradually, in a single quarter. DRAM contract prices are surging 90 to 95% in Q1 2026, and Apple just announced they're rationing memory to their premium iPhones only. The standard iPhone 18, pushed back to 2027. This is what happens when AI infrastructure build-out collides with physical reality. There simply aren't enough memory chips to go around. And while this crisis unfolds, the semiconductor industry is simultaneously attempting something that's never been done before: deploying humanoid robots inside chip fabrication plants. STMicroelectronics just became the first semiconductor company in the world to put humanoid robots to work in their factories. If you want to understand where AI and advanced manufacturing are actually heading, not the hype, the reality, you need to understand what's happening right now. STMicroelectronics, one of the world's largest semiconductor companies headquartered in Geneva, with over $40 billion in annual revenue, has just signed a groundbreaking agreement with Italian robotics company Oversonic Robotics. The deal brings Robi humanoid robots into ST's chip manufacturing facilities, marking the first time any semiconductor company has deployed humanoid robots in production environments. The first Robi unit is already operational at ST's advanced packaging and test facility in Malta, with plans to expand across multiple ST plants globally. And this isn't some warehouse or logistics center. This is a chip fab, one of the most demanding manufacturing environments on the planet. Let me explain why this matters. Semiconductor fabs operate under cleanroom conditions where a single speck of dust can destroy millions of dollars in chips. Workers wear full bunny suits. The air is filtered to remove particles smaller than a human hair. Temperature and humidity are controlled to fractions of a degree. These facilities require micron-level precision, that's 1/1,000,000th of a meter. Robi is designed specifically for these challenges. Built by Oversonic, a company founded in 2020 in Italy's Lombardy region, Robi stands up to 2 meters tall and features 40 moving joints. It can operate autonomously for up to 8 hours and function in temperatures ranging from 5 to 50 degrees Celsius. The robot uses depth cameras and advanced navigation algorithms to move through complex spaces while avoiding obstacles. Critically, Robi is the only humanoid robot certified to work in both industrial and healthcare settings, meaning it's already passed rigorous safety standards for operating alongside humans. STMicroelectronics President of Quality Manufacturing and Technology, Fabio Gualandris, stated that their ability to deploy automation at scale is a key parameter for long-term competitiveness, calling humanoid integration the next frontier. This deployment represents a validation milestone that the entire robotics industry has been waiting for. If humanoid robots can function reliably inside a semiconductor cleanroom, the most precision-demanding manufacturing environment that exists, they can function anywhere. Think about what this proves. Chip fabs aren't just clean, they're hostile to anything that sheds particles, generates heat unevenly, or moves imprecisely. If Robi can handle pick-and-place operations, machine tending, and logistics flows in this environment without contaminating wafers or disrupting production, the technology is ready for mass industrial adoption. The timing is significant. The semiconductor industry is facing unprecedented labor challenges, while simultaneously racing to expand capacity. New fabs are being built across the United States, Europe, and Asia as part of global reshoring efforts. Each facility needs thousands of trained workers. Humanoid robots that can integrate into existing human-designed workflows without requiring complete facility redesigns offer a potential solution. This also signals something important about the robotics industry's maturity. Oversonic isn't a well-funded Silicon Valley startup. It's a 65-person company from northern Italy. The fact that they've built a humanoid capable of passing semiconductor industry standards suggests the underlying technology has reached a point where focused engineering teams can deliver industrial-grade solutions. The key metric to watch is expansion speed. STMicroelectronics has committed to deploying Robi across multiple plants globally. How quickly that rollout happens will signal whether this is a successful pilot or a transformative shift. Oversonic will also be demonstrating Robi at CES 2026, showcasing applications specifically developed for advanced manufacturing contexts. If other major chip makers follow ST's lead in the next 12 to 18 months, It will confirm humanoid robots as a permanent fixture in semiconductor manufacturing. But while semiconductor companies are preparing for a future with robot workers, they're dealing with a much more immediate crisis. The very memory chips these fabs produce. There aren't enough of them. And the shortage is about to get dramatically worse, because AI infrastructure is consuming memory faster than the industry can manufacture it. According to TrendForce, DRAM contract prices are projected to surge 90 to 95% quarter-over-quarter in Q1 2026. PC DRAM specifically is expected to increase over 100%, doubling in a single quarter and setting a new record for the largest quarterly price surge ever recorded. NAND flash isn't far behind, with prices expected to jump 55 to 60%. This isn't a temporary supply chain hiccup. This is a structural crisis driven by a fundamental relocation of manufacturing capacity. The three largest memory manufacturers in the world, Samsung Electronics, SK Hynix and Micron Technology, are pivoting their limited cleanroom space and capital expenditure away from standard consumer memory and toward high-bandwidth memory, or HBM, for AI applications. HBM is the specialized memory required for AI accelerators like NVIDIA's GPUs. Here's the critical detail. HBM production consumes approximately 3 times the wafer capacity of standard DRAM per gigabyte. Every wafer allocated to an HBM stack for an NVIDIA GPU is a wafer denied to the memory module in your laptop or smartphone. The numbers are staggering. Industry analysts report that up to 70% of memory chip products created globally in 2026 will be destined for AI data centers. SK Hynix reported during their October earnings call that their HBM, DRAM and NAND capacity is essentially sold out through 2026. Micron has exited the consumer memory market entirely to focus exclusively on enterprise and AI customers. DRAM prices have already risen 171% year-over-year. DDR5 spot prices have quadrupled since September 2025. And SK Hynix predicts this shortage will persist through late 2027. This is the hidden infrastructure crisis that constrains every AI company's hardware roadmap. Everyone talks about GPU shortages and model training costs, but memory is becoming an equally critical bottleneck. The implications cascade through the entire technology ecosystem. Apple just announced during their January earnings call that they're prioritizing production of their 3 premium iPhone models while pushing the standard iPhone 18 back to 2027. Morgan Stanley analysts confirm Apple has locked in NAND supply through early 2026, but only by accepting sequential price increases of more than 50% for DRAM. PC prices are expected to rise 15 to 20% in Q1 2026. IDC projects the global smartphone market could contract by nearly 3 to 5% this year as manufacturers struggle with component costs. Hyperscalers will pass memory cost increases through to enterprise customers, raising the price of cloud computing. This is a zero-sum game playing out in real time. The AI build-out that's supposed to transform the economy is simultaneously straining the infrastructure that economy depends on. Bank of America estimates the HBM market alone will reach $54 billion in 2026, a 58% increase from last year. That money has to come from somewhere, and right now it's coming from the consumer memory supply chain. Watch for capacity expansion announcements. Samsung is reportedly planning to increase HBM production capacity by 50% in 2026, while SK Hynix has announced infrastructure investment increases of more than 4 times their previous figures. Both companies have accelerated HBM4 production schedules, moving mass production forward to February 2026 to meet NVIDIA's Rubin architecture demands. The question is whether new capacity comes online fast enough to relieve pressure on consumer memory, or whether AI demand simply absorbs every additional wafer produced. The future of manufacturing is arriving simultaneously on multiple fronts, robots entering the most demanding factories on Earth, while the components those factories produce become increasingly scarce. The question isn't whether these changes will reshape the technology landscape. It's whether the industry can scale fast enough to meet demand without breaking. If this kind of analysis helps you understand where AI and tech are actually heading, subscribe. There's always something happening in this space, and the details matter. See you in the next one.